Thank you. Sorry, there are still people joining. That's why I'm not starting. And maybe we have a few problem with slowness of internet in everybody coming in. So be patient. Please. So maybe I will start now. I'll give it another 30 seconds. Let's see if we have more people joining. Okay, so welcome everybody. Good day, good afternoon, and good evening, depending on your longitude. And thank you very much for attending today this very exciting seminar or webinar about the earthquake performance of school buildings in Indonesia. Lesson learned from a number of recent earthquakes. Indonesia is one of the places on the earth at highest, where the earthquake hazard is highest and most diffused throughout the whole territory. The seminars will be presented by Dr. Yunita Idris and Mr. Adrian Ulsa with the support of Dr. Ella Melianda, all members of the Tsunami and Disaster Mitigation Research Center. Dr. Yunita Idris is a senior lecturer in civil engineering department of Siyawala University and is also the coordinator cluster of disaster resilient infrastructure in Tsunami and Disaster Mitigation Research Center at the same university. She is involved in several post-earthquake buildings damage surveys in Indonesia. I should also mention that the DRR&RE has been in existence since 2006. So soon after, it was established soon after the very damaging tsunami of 2004 that destroyed the whole peninsula of Banda Aceh. And they have been extremely active and extremely successful in disseminating a culture of resilience during the rebuilding in those regions and further ahead through Indonesia. They have also been extremely active on the international scene, connecting with many other international organizations, and we have been learning a lot from them, and vice versa. There have been some very positive exchange in the past, some of which will be presented in the presentation shortly. Mr. Adrian Hulsa is a structural engineer. He has joined the center recently, and it's currently also taking a PhD. At the center is actually involved in the vulnerability of municipal buildings, including school buildings in Indonesia. There are some more attendees that are coming. Before I pass the screen and mic to Unita and Adrian, I will just like to give you a few news from the chair. So this is as you already familiar with, for the ones of you that are already joined us several times. This is the program of seminar, webinars, short courses that we have been delivering since April last year. And this today is the last for this academic year, let's say, but we immediately will have news for the summer. You can find all the information on the courses and the short and the recording and on this website. So please go and view them, and feel free to download and study and use the course materials for studying or for further use in your everyday professional life. But also send us information, feedbacks, and suggestions for other courses that you would like to see. Very briefly, I want to point out that this year, the UNESCO UK Chairs and Antwin Network held a conference at the end of May, looking at what, and these are the people that host and hold, so they are my colleagues that hold UNESCO Chairs in the UK, and to look into collaboration across the UK Chairs networks to achieve the Sustainable Development Goal. The 2 days of conversations resulted in this mapping of the activity of the UNESCO Chairs in relation to different CDGs. And as you can see, the majority are involved in the educational Sustainable Development Goal, but we cover a wide remit of them. And this mapping is evolving as we establish new connections internationally, but also new connections among ourselves. But what I would like to mention today, and I will do so across the summer, is a plea to let us know which CDG are you working to meet. And if you can please send us a brief summary of what are you doing towards the CDGs, and send an email to the UNESCO Chair in DRR@ucl.ac.uk. We want to produce a similar mapping for all the people with whom we are connected through this series of webinars. So please, and through all our friends out there. So please do so, and we will update the mapping as we go through new installation of the seminar. Finally, I would like also to mention the fact that in the next few days, we will run summer school from Universidad de los Andes physically in Bogota, but in fact, the summer school is available also online. So if you're interested in structural resilience and vulnerability, you are very welcome to register and to follow up the information that you can also find on our website under the news and on LinkedIn. Finally, the next installment of this series of webinar will be on 13th July 2023. It will be about the management of the post-disaster relief, recovery and reconstructions in the aftermath of the Kahramanmaraş, Turkey earthquakes. We are still in the early days in terms of recovery, as indeed we are looking at just less than 4 months have elapsed since the occurrence of the earthquake. But it's very important to look at this initial phase in details. And two colleagues from UCL, Yasmin Diden-Akças and Cassidy Johnson, will be presenting together with a colleague from Antakya, Ali Tolga Ojdel, which is on site there. Thank you very much. And with this, my presentation is complete. So I look forward to meeting you again soon on the 13th of July, sorry. I will like to then pass the mic and the screen to Unita and Adrian. Adrian, you will be sharing the screen, I believe.
Yes, thank you, Dina.
Yes, and then just to say that we will have a question and answer session as usual at the end of the event.
Thank you.
Yes, Adrian, there was a problem? Yes, this is coming. Maybe you need to click on the slide view, resume slideshow. That's perfect. Okay. We still have the problem. No, this slideshow. Yes.
Is it fine right now?
There is still that shade on your right.
Yeah, I think there's trouble. Wait. I'm not sure. What is this?
If there is nothing in front, it might be refreshing soon. Or if you prefer, I can share.
Yeah, something is trouble now. The shade on the left, I don't know. What is it?
Is the news, the updated slide still in the drive that we share, right?
I've just downloaded it a few minutes ago, so they should be updated.
Okay, while we're waiting.
Let me know if you can see my screen.
Yes, we can see that. But need to be in the slideshow mode. Maybe.
Yes, just a second.
Thank you.
Can I try it again, Prof. Dina? I think I solved the problem now. Yeah. Okay.
Okay, good day everyone. Sorry for the technical issue. Thank you for Professor Dina Dayala for the opportunity to present one of our research topic today. And as Prof. Dina Dayala said in the introduction, we already had many collaboration with Epicenter and UCL, including for assessment of the schools, like one of the project with Professor Carmine and also with Professor Tiziana Rossetto. Now, we would like to present one of the research topic that we currently developing in our center, in Tsunami and Disaster Mitigation Research Center, TDMRC, at Syekh Kuala University. The topic that we will discuss here is the performance of the school buildings in Indonesia based on the lesson learned from destructive earthquakes that have occurred in the recent earthquake, namely Cianjur and some earthquakes. And next, this presentation will be divided into 3 stages. That the first stage will be an introduction to the Indonesian seismic map for the year 2022 and about the archetype of the school buildings and the regulation of the school buildings, and also the history of the earthquake standard in Indonesia. And for the second part, we will talk about the glossary of the typical damage states that happen in the school buildings. We will start to show about the Palu condition. And at the third case, we will have talk about the Cianjur earthquake, the information about the assessment that we've done with the post-earthquake assessment for the school buildings in Cianjur, Jawa Barat, Indonesia. Next. So as we can see from the screens, that the earthquake distribution data that released by the Indonesian Meteorology, Climatology and Geophysical Agency for 2022. There were many recorded shallow earthquakes ranging from 2.5 magnitude to over 5.5 magnitude, and the red it labeled as the red dot. These earthquakes have the potential to cause damage, especially when they occur near communities and have a magnitude greater than 5. It can be concluded that Indonesia faces a significant threat from destructive earthquakes. Next, please. Now we talk about what standard that we've been used for the earthquake in Indonesia. So we have the old generation, and then we will talk about the next generation. Starting from 2002, we start to have the standard earthquake code, seismic code. In 2002, with the adoption of IBC 97, our standard is SNI, National Standard SNI 1726 2002, with the reference of IBC 197. But for the reinforced concrete structures, we use SNI 2847 2002, year 2002, that with the reference with the ACI 318/99. But for the minimum load for the design, still using the SNI 1727 year 1989 in 2002. But started from 2010, the national earthquake map of Indonesia was first released, And consequently, in 2012, we have the updated seismic code, national seismic code for SNI 1726 2012 that adopted ISCE 7 and 10. That also the code for the reinforced concrete structures and also the minimum load is follow being updated. And then in 2017, after the earthquake, PD Jaya earthquake, because in PD Jaya there's a missing fault that not notably. So the national earthquake map of Indonesia then updated in 2017, followed by the updating of the seismic code for SNI 1726 2019, and also for the minimum load. Minimum design load, including flood, tsunami, and also wind, that being included in 1727 national standard. And the recent earthquake events have shown an increased probability of high intensity levels in certain region of Indonesia. That's why the earthquake map is the earthquake hazard map is being updated. The change in the earthquake map have also led to the revision of the building standard, as I mentioned previously, and both for minimum assessment standard and construction guideline for reinforced concrete buildings. Specifically, in 2020, the Ministry of Public Works and Public Housing, PUPR, issued a technical guidelines for school buildings, encompassing standards and guidelines for buildings ranging from primary schools to high schools. Please, next, please. Next, please. Now, based on SNI 1726 2012, the national standard earthquake for Indonesia, and 2019, the earthquake intensities and the probability of building performance is categorized into 4 risk levels related to the 5 target building performance. These 5 targets are adopted from ASCE 716. However, in SNI 1726, the earthquake importance factor in Indonesia emphasized to the occupancy of buildings. The earthquake importance factor is categorized into 4 groups of risk levels. Important factor 1 is for the temporarily occupied buildings such as a warehouse and also the security office. But the office buildings and residential buildings fall into group 2, and the highest priorities group, which is the schools, place of worship, like a religious place, and hospitals fall into group 4. Yes. Next, please. But for school building, the Ministry of National Education also issued a regulation regarding the standard for the school facilities and infrastructures, which are outlined in the Ministry of National Education Regulation number 24 of 2007. This regulation was subsequently strengthened by the Ministry of Education and Culture Regulation number 22 of 2023. This regulation covers various aspects, including the location, room capacity, and the ratio of number of students to the building area. As we can see from the screen, sorry for the small letter here, that the elementary school has minimum like 6 classes and a maximum of 24 classes. It is included in this regulation. And if the population like exceeding from 2,000 individuals, then additional classes could be added to existing school. But if the number exceeds from 24, then a new elementary schools need to be built. And the minimum of the school building for the elementary school is one village or one sub-district. So one sub-district is served by a minimum of one elementary school. And but it will be different but for the distance from the farthest student housing. I mean, not student housing, I mean the maximum walking distance for student from their house to the elementary school, it's like 3 kilometers, but for the junior high school, like about 6 kilometers. And the standard for the classroom is that the minimum number of the classroom is equal to the number of classes. I mean the group of students. And the maximum capacity of classroom is 28 students for elementary schools and 32 students for junior high school. And the maximum minimum area ratio of classroom is 2 meters square per student. And for classes with fewer than 50 students, the maximum area is 30 meters square. And the minimum width of the classroom is 5 meters. Next, please. Next, please. Yes. It is the specification for the school buildings from elementary to high school are described in the technical guidelines issued by the Ministry of Public Works and Public Housing, PUPR, under number 47 /SA/DC/2020. These technical guidelines cover building standard, construction details, and implementation guidelines, and also the detail of the construction. The detail of the reinforcement of the column and the beam. The technical guideline provide detailed standards for the typical buildings that to the seismic design category class. They even include specific reinforcement details, like I said, for the beam and the column reinforcement. The guidelines also include a typical design for they define that the shape of the schools and the typical construction that. For the single story is the confined masonry structure buildings, and the 2-story buildings and 3-story building is with the reinforced concrete structures. The typical construction equipped with the detailed building elements in the technical guidelines follow the typical construction types in Indonesia. And also they also include the assessment, the way to assess the damage that for the assessment, damage assessment of the schools. Next, please. Next, please. Yeah, talking about the typical construction for the school buildings in Indonesia. So based on the Permendikbud, I mean the regulation of the Ministry of Education in the previous slide, It is mentioned that the number of school in a sub-district is depend on the population. So because and also the area of the classroom and the area of the schools and the number of the classes depend on the population. Now, majority of school buildings in remote area, what I call it remote, not only remote area, but the less population of students have one-story buildings. Now, so we could find majority of, the city could be like two-story buildings, like accommodate the population. But for the less population, like in the not in the capital city of the province, it's normally one single story of building. And the typical construction are lightweight frame that could be categorized as the frame or the confined masonry. But some of the older schools sometimes have the frame made from timber. Okay, next. This is the typical of the two-story school buildings. So this these schools that we presented here in the slide is from the Banda Aceh schools. Banda Aceh school, our city, our capital city of Aceh province. So the typical construction for the two-story school building is the reinforced concrete structures that with a bay with around with a beam spans of approximately 3 to 4 meters and a column cross-section dimension of around 300 and 400 millimeter. Okay, next, please. So, as most schools buildings in Indonesia are over 10 to 20 years old and some even have heritage status, therefore the performance of these buildings during earthquake may not meet the standardized design criteria set by the latest national standard and recently issued technical guideline. In the following slide, we will present the observed performance of school buildings, the typical damage state of the school buildings that happened in Palu earthquake. We use the data from, the UNDP Petra, and the following stages, as I mentioned in the outline, we will present the observed performance of the school buildings during observation of the Cianjur earthquake in 2022. The Palu earthquake, which occurred in September 2018, resulted in damage and losses of approximately 900 million US dollar. And the Palu earthquake was accompanied by a tsunami and landslide due to the liquefaction. In the same year, there was a strong earthquake that caused significant damage in Lombok region in 2018. But for this presentation, we will maybe talk more about our observed earthquake performance of the school building for the recent earthquake, which is the Cianjur earthquake in Jawa Barat, the West Java. That had caused around 1.2 billion US dollar, with the magnitude of earthquake is about 5.6. Okay, next, please. Now, this is the seismicity of the Palu earthquake in 2018 that caused the loss of the 900 million US dollar. And next, please, I will show the sum of the damage state of that can be concluded from the observation from the data of UNDP Petra project. We also have the recognition survey with Professor Tiziana Rossetto for the earthquake in Palu. But for here, I will conclude from the UNDP Petra project. And here, the typical of no damage state, DS0. And next, please. And this is the slight damage that happened, that categorized as the slight damage, where only the height with a crack on the wall and no significant damage on the frame and also from on the wall. And next, please, for the next stages of damage, moderate damage, DS2, we can see like most of the roof that we use for the school buildings, mostly gable roof, that having the gable, the most of the earthquake performance in the gable roof, like we lost the gable, and then and also the failure of the connection between the opening and the wall. This what we show you is the typical of the confined masonry structure for the school buildings. And next, please. And this is the DS2 moderate damage. Also the moderate damage. And then next, I think it's similar to the next, please. And this is also DS2. You can see that mostly some of these school like having the ground failure that make the local settlement for the walls. And then next, please. This is that categorized from the data that DS3 extensive damage, that they have loss of all of the roof and roof construction, and the massive damage of the walls. Okay, next, please. So this is completely lost. Yes, next, please. So this describe the typical damage states of the school buildings, and then we will going to the observation of the school buildings in Cianjur. Next, please. So for the Cianjur earthquakes, I will ask Adrian to presenting more detail regarding the earthquake performance of the school buildings that we observed in the recent earthquake in 2022 Cianjur earthquake. Please, Adrian.
Yeah. Okay, thank you, Yunita. So I'll try to present what we have seen in the case of 2002 Cianjur earthquake. So actually, we according to the news and also from what we see, the magnitude of the Cianjur earthquake is not really big. It's only 5.6. But since the location of the source is really shallow, about like 10 kilometers, we can see that so many building is destroyed and a massive and significant building is collapsing. This is one of the village in Cugenang, Cianjur, the aerial view from the drone photo shoot. So the village is totally destroyed, and actually the residential house, it's only one-story buildings. Some of it is two-story buildings, but as we know that the one-story buildings actually is not really exposed to the damage because of it's not really have a mass. So during the earthquake excitation, it's actually not really absorb the energy. But in this situation, we have seen so many one-story building is destroyed, especially for the residential houses. And the method what we conduct in the Cianjur earthquake, we are using the epicenter rapid visual survey forms, which is the epicenter is really knows, and actually there are some of available survey tools like ATC20, and also we have two of methodologies from the national standard like post-disaster need assessment from the National Agency for Disaster Countermeasure. And also we have the house affected by disasters methodology from the Ministry of Public Works and Housings. And as mentioned previously in the UNITA slide, the Ministry of Public Works and Housing also have a technical instruction for design and standardization and damage assessment of schools, such a follow form. So in this detailed form, there's really detailed computation of how to determine the building is the degree of damage severity is computed based on the percentage of the damage, and really takes a lot of times to adopt. So at the moment, we decide to follow with the epicenter RVS form. I think the epicenter is really familiar with this criteria of the definition of damage stage, but please allow me to emphasize it again. So for the damage stage 0, it's dictate that no visible structural or non-structural damage observed during the survey, while in the damage stage 1, the structure components is having no damage, but the damage is limited to the non-structural element only. And for the damage stage 2, the structural the structural will perhaps have a damage but not causing a collapse, and crack up to 3 millimeter in mezzanine walls, and also the heavy damage to the collapse of non-structural components like roof cover and gables or parapets. For the damage stage 3, the extensive damage, the structure is really severely damaged, but the structure is standing, and the out-of-plane failure is causing the collapse of masonry walls panels, and the roof structure is really heavily damaged, and excessive foundation settlement and tilting is apparent. In summary, the collapse of the buildings predicts up to 70% of non-structural components such as roof cover and gable or parapets. And for the last one, the damage stage 4, the building is already completely damaged. Firstly, I want to emphasize it again about the situation of the schools of what we see in the Cianjur earthquake, because the building is actually really old, and actually even though the column is relatively bigger than the masonry wall, but since it's likely reinforced, so we consider it like as a masonry structure. Okay, this is one of the example of damage state 1. As we can see, a small cracks is apparent in the buildings, on the walls, and the damage is very limited to the non-structural components only, and we consider it as damage stage 1. Next one is the damage on the ceiling and truss of the structure of truss. since Indonesia is a big country, it's very diverse in the material and also the technology of the constructions. In Java, we observe that the many old buildings is adopting the clay roof tile for the roof cover. But during the earthquake shake, it seems that the clay roof tile have a bad interlocking between them. So it caused the clay roof tile falling down, and it's broke the ceilings like this picture. And also we have ceilings that form from the bamboo sheet, woven bamboo sheet. So it's really fragile, and the falling down of the clay roof tile is really make the ceiling destroyed. This kind of damage, we consider it as damage stage 2. Another case where the collapse of roof system is occurred, we consider it a damage stage 3. Right now, at the picture, we can see we can see that the roof, the truss is adopting cold form truss, and also collapsing. It seems that because of the falling of the clay roof tile and make it really vulnerable, and it's really bad damage. The timber structure of truss is also being damaged, as can be this figure. Another example of damage is what really typical in the school buildings. What we found is that the Gable Wall. So at some degree, a horizontal crack is apparent, and it seems like separate the Gable Wall to the bottom of the masonry wall. And when the crack is propagating and the damage is more severe, the Gable Wall is completely damaged, like the following picture. And the next one is really having a bad destruction. Okay, this is another example of the wall failure. It seems that at the following picture, the wall is disintegrate from the reinforced concrete column because there is no double bar. Usually in current practice, we adopt the double bar to interlock the masonry to the column, but at situation and condition, it seems that there's no double bar is introduced in the design. And second picture is also show how severe the damage to the wall. And what surprising us is perhaps maybe moment the construction technology is not really good as right now, and it seems that the concrete quality is not really good. So firstly, the plaster, the color of the concrete is not really represent. We actually see like a gray color, but at this situation, the concrete color resemble like a dirt or a ground color, like a brown. And another case is where we considered is as damage state 4, where the buildings, or I mean the masonry wall is completely collapsing. Okay, this is what we also found, a very interesting case where the column is disintegrate. The second floor of the column is disintegrate from the first story. Because of the situation, we should not really safe, so we are not trying to get closer, but after we inspect it again, it seems actually really interesting what happened in here. Maybe some bad reinforcement joint in here, so the connection of the first floor and second floor is disintegrate, so the structural column integrity is really compromised. We also found such as, I'm not really sure, but maybe it's like in plane failure of the wall, like back and forth reverse motion during the earthquake, like we have see like a diagonal strut back and forth, so it caused a falling and fail of the masonry wall. And another issue is also we see very thick of mortar or plaster, concrete plaster that detached from the concrete column. And we also observe some typical failure in the gable wall. And this is also the main problem that we see in the school buildings failure. As you can see that the reinforced concrete column is actually bigger than the, so it's probably not resembling as a confined masonry, but this is what me and Unita actually at the site is arguing about, whether is this confined masonry buildings or is it a reinforced concrete masonry infill, because of the size of the column. But when we go deep thoroughly, we see that the reinforcement is really likely, and like the longitudinal bar is really small, and also how big the space between the confinement spacing. It's like figure, it's the confinement spacing is around 3 times of the column width, maybe around 400 millimeter. But for the inside, actually the current standard from the Ministry of Public Works, I mean the archetype buildings of school buildings, dictate a minimum reinforced concrete column like 50 by 200 with 6 deformed bar of 13 millimeter size. So close spacing of confinement like 150 millimeters. And this is what typical when we design a buildings adopting SNI 28047 2019, which is adopting the ACI 31814. In the seismic design category D, the typical confinement will be 100 and also 150 millimeter, while the size will usually for the structural, it's around 10 millimeter and also 13 millimeter. And not to mention that we also have to design the cross ties. So it seems that our knowledge about the seismic design, seismic earthquake resistant design is evolving, and also the standard on how we treat the occupancy of school building like schools and hospitals is really a concern. That also raised a concern to the older buildings such as a school in Cianjur, which also will become vulnerable because it's adopting older knowledge how well it can perform during big earthquake. So this is the highlight of our assessment. Firstly, we suspect that despite of the shallow of earthquake source for the structural part, we want to emphasize that perhaps one of the culprits of the failure is because concrete quality. Like you can see at the picture, the visual color of the concrete is resembling like a dirt color, kind of like a brown, not as a gray like usually a concrete is. And also some structural issue such as not really close confinement spacing like this one, right? And also really small reinforcement, longitudinal reinforcement size. And another typical construction, typical problem in older construction is at the of the concrete column and also the beam. As we can see, the failure is happening at the joint at this structure column, and it perhaps what we have concern is because there's the absence of the confinement at the joint of the concrete column and also the beam. Okay, this is the spatial distribution of the damaged building that we have been surveyed. It's not conveying all of the schools in Cianjur with total survey school of 48 building, 48 schools, I mean, and the total buildings is around 230. And mostly what we survey is actually the elementary school, which is up to 39 buildings, and 6 for junior buildings and 2 senior school buildings. And mostly the damage state 4 is high damage state is concentrated at the fault line. So we also try to model the earthquake using OpenQuake from global earthquake model and using the Scandinavian simple fault calculation with GMPE model using Cambodia 2014. Actually, this computation is not really final. We had to consult with our earthquake and seismic, but for this presentation, we want to reveal to the participants that the failure of the damage of the schools is actually perhaps resembling damage near at the fault line. So I think that conclude my presentation, and I giving it back to Unita.
Thank you, Adrian. Let me concluding the presentation for the next slide. So I might say that the school standard in Indonesia have been updated to accommodate the standard of safety for potential hazards such as earthquake. And most of the school buildings had been built more than 20 years ago, and that's why it need to be upgraded and to meet the standard. In different location of observed area for the strong earthquake, the performance of the school building shows that the probability of collapse is quite high, and the potential extensive damage could occur in the intensities around 0.4 G. And the most common damage could be found in the failure of bearing walls due to the lack of reinforcement in the structural elements and the concrete quality issues. That's all what we could say for today. Maybe it's still limited because it's still under developing research. Thank you very much for the attention.
Thank you very much, UNITA, for a very interesting presentation showing several aspects of the damage. There is a first question, and please, others that wish to ask question, either write it in the chat or raise your hands so that you can then utter the question yourself. So from Sam Schumer, the question for UNITA is how government and state and municipal authorities in Indonesia are trying in practice to support earthquake resistance of school buildings in poor and low socioeconomic regions of Indonesia.
Okay. Thank you for the question. It's a bit hard to answer because it's about the policy and the practice of the governments, because we are not really in that area. But I must say that what we observe and then what we learned, that as I presented in the beginning of the slides, that we already update, the government already concerned about the earthquake performance of the school buildings, and there's also the regulation about the requirement of the location of the school building, even in the remote area, that related to the number of the students that could be potential in that area. So the school building for the senior, the elementary and the junior high school is what do you say that it's under the coordination of the city municipal, or I mean, yes, the cities, like we call it district of the Department of Education. So we have the center, I mean the Ministry of Education, and then we have the provincial department, and then under the provincial department we have kabupaten. We can call it district, yeah, under so the senior, junior, and also the junior high school, SMP, SD, and SMP is under the coordination of that department. So anything that related to the infrastructures and physical infrastructure, and also other needs of the schools, is under the coordination of the school. So including, I mean, the maintenance, and also the yes, maintenance of the school buildings. But for the senior high school is under the coordinating of the provincial department. So yes, I mean, the upgrading of the school building into the seismic hazard, I think it's still become the concern of our governments, like what being practiced in Cianjur. Government tend to build the school, they call it the seismic resistant structures, that made by the precast, kind of the precast concrete that can be like a knockdown structures, and it's a very light structures, and also it's called Risha. It's a precast concrete, and it is believed that it could be like accommodate the heights. It could be like reduce the risk of the earthquake hazard. Yeah. So maybe Adrian would like to add. No. Okay.
Okay, thank you very much, UNITA. I think there is another question from Kautar on a similar issue. But first, I would like to ask, of course, the school technical guidelines for standardization of the school design and the damage assessment have been issued in 2020. So it's still early days to see how much this will impact on the, let's say, vulnerability of the schools at a national level and at system level. Do you have an idea of how many have been rebuilt following these guidelines?
Oh, it's a 2020. Yes, it's a 2020. No, I don't have any data to answer about that. But for the damage, school damage that happened after the earthquake, yes, they built under that standard, I think.
Are all being rebuilt to these standards?
The new building, yes.
That's good. And as you said earlier, in this standard, there are quite detailed guidelines also for the reinforcement. For instance, that needs to be put in the new concrete frames and so on. I think there is a question here about from Autar about what retrofitting has been made, or what retrofitting provisions are there for the old buildings that have not been damaged yet, but that hopefully will be retrofitted before the next earthquake.
Yes. So also so there is a reconstruction, but also have retrofitting for some schools. Here after 2004, maybe we see the nearest, location that we could observe. Yes, some of the retrofitting done by replacing strengthening the structural member, such as the column. They retrofitting the columns, and maybe Adrian could help me with the some practices that you ever experienced with retrofitting some buildings in Aceh.
In Aceh is actually being hit by the tsunami. We also right now have an issue with the structural components that disintegrate because the salt attack. It makes like the reinforcement corroded, and also the concrete is decaying. Some of the buildings is actually like the column is explode because of the really severe damage of the corroded reinforcement. So the current practice that, because right now we doesn't have like a solid methodology, standard how to do the thing. So usually the consultant will use the concrete jacketing, and also try to introduce some FRP strengthening. But some of the buildings that really doesn't have an exposure of like donation, like the budget, so it will like strengthened by the worker that not really have a good knowledge. So they just patching the concrete that disintegrate with a new concrete without a proper concrete jacketing methodologies.
Okay, so you're saying that there is a need for developing and training for technology for retrofitting appropriately. There is another question about the parameter that is shown on your hazard map, whether if it is peak ground acceleration or spectral acceleration.
It's in terms of peak ground acceleration.
Sorry, it's peak ground acceleration.
Peak ground acceleration.
Okay. And then the following up questions is if you have managed to identify that site conditions affects and they are considered in the hazard map. Of course, in the post-earthquake survey, you have identified that it's really close to the fault that the structures have had the greatest problems. But what about just the soil site condition?
Yeah, for the site condition, like the VS30, we inferred from the USG model is like 600 around 600 millimeter per seconds.
Mm-hmm.
Yeah.
Okay, so they are, and this is for the latest earthquake or for the overall hazard map, or
It's for
this
the
is this is the reference used for the whole hazard map.
Yeah, it's actually independent computation from us, but actually maybe the government have also revealed and also tried to modify some parameters, because right now there's a debate for the fault line that about the situation of the fault line, and I'm not sure, but when the earthquake struck, some of people is trying to argue which one is correct fault line, like that.
Yes. And also I think the government already like upgraded our earthquake hazard map as well, like so, but it's still being like socialized to nationality after the earthquake of the 2022.
Disseminated for people and make it use this particular hazard map. Yes. I have a question that myself that relates about more the typologies that you are identifying. From the pictures that you have shown, it seems to me that these typology are more confined masonry, that not, let's say, reinforced concrete masonry infill structures. With clearly, in some case, lightweight roof, in some case, heavier weight roof, but very rarely with roofs that are sufficiently stiff to redistribute the action. How would you classify these buildings yourself?
In the from the
sites that you have visited, and but also yes, my follow-up question would be the guidelines on the archetype contained in the guidelines. Are they to be considered confined masonry, or are they to be considered reinforced concrete? Because clearly the design will change substantially depending on that.
Yeah. From the side, I might say that it confined masonry, because mostly the load is the wall is become the bearing wall. I mean, because the load is like supported by the wall mostly for the roof construction, but but they show like some kind of the bigger dimension of the column. I mean the column. But when we see the rebar, I mean the reinforced bar, it's the size is kind of the only for framing the wall, and most of the load is like being supported by the walls, but not from the JUKNIS, I mean, from the regulation of the PUPR, what is this called, Adrian? Is it the confined masonry or tembokan? We say that tembokan or reinforced concrete.
Yes, actually, the confined masonry term is not really popular in our codes.
Yeah.
So yeah, we call it like practical column and also practical beam, like that, like
Yeah.
like
Okay.
tie beam or tie column, like that.
Okay, so but they are meant to be ties. They are not meant to work in bending, and they are not meant to transfer moment at their connections and be load bearing in the same way that they would be in a reinforced concrete frame. Is that correct?
Yeah.
Okay, that's quite important, because then the level of confinement becomes very important in relation to the overall capacity of the structures, and therefore the way in which the walls are confined becomes very important.
Yeah.
Thank you very much. So there are some more questions. One from Gary de la Pomeray says that column exploded due to rebar oxidation. So do you see water penetration at the top of the pillar or the floor joints, or column exterior cladding deteriorated? What was the reason for the loss of cover concrete in other?
Well, it's a personal project. Actually, it's not related to the schools. It's a private buildings. So it's commercial building, cover to the columns. So when it happens, actually the building is settling the second like 5 centimeter. Because of the cover, we cannot see how the damage is propagating. But when we try to open up the cover, the reinforcement is really severely corroded. And the owner of the building is also mentioned about the building is hit by the tsunami, but not the impact, but I mean the raise of the like that. So we suspect that the first story is having really bad severity of rebar oxidation. So I'm not seeing like the water penetration from the top, because at that moment, and also we have so many cases where the concrete cover is falling and we see the reinforcement decaying because of the corrosion like that.
So you think that it's mainly because of the vicinity with the ocean that this has occurred, and over a period of 20 years. So, but yes, you also reference to the quality of the concrete. I think you seem to indicate that either there was not sufficient cement paste, or that the sand was not quite clean sand, but there was also clay in it because of the color of the concrete. Is that correct?
Yeah, the situation is actually specific in Aceh area, and it's not related to this our presentation. But what we can confirm that the most of the buildings that have that typical damage is within the coverage area of tsunami that hit in 2004. So that's why we suspect that because of the tsunami water that penetrate the reinforcement and make it really.
So even where buildings survived the tsunami, they have deteriorated because of the weight and time. And in fact, Gary also is asking whether you have ascertained that for the columns, it's a structural failure of the columns, or it's a design failure, or it's lack of maintenance.
Yeah, it's really difficult to do our understanding about the, I mean, non-engineer, like the owner of the building is mainly not the non-engineer person, so they are not aware of such condition will harm their buildings and also maybe harm the person. So yes, it will trigger a structural failure sometimes, and like what I mentioned, one of the building is the color, and it's the sound is really big, and the owner of the building is shocked. What actually really better is that because of the column is covered by a facade, so the propagating crack is not apparent. So when it happens, it happens. So bad lucks for the owner. So we try to, because of trying to save the assets, we try to do the concrete jacketing, and before that, we also try to make a temporary support, like installing a shoring system like that. When during the construction, we also actually hear some crack, like, is it building gonna be safe like that? But for right, the retrofitting is in the end of 2010 to 2012, if I'm remember it correctly, and it survived right now. So with the consequence of the column is really big right now. From the beginning is only 30 by 30 centimeter. Right now it's like 60 by 60 because of the conventional methodology of the concrete.
Okay, thank you very much. I don't know, Gary, as you have your camera on and you are there, if you want to counter comment on the answer.
Yeah, thank you very much. Yes, a good presentation.
Can you introduce yourself for the rest of the audience? Thank you.
Okay, thank you. Yes, Gary Del Pomeroy. I'm sort of honorary chair of a task force for the built environment within UNESCO, which we're sort of trying to reinvigorate at this present time after a few years. And I'm based in Nepal, working with schools, school safety and education on disaster risk reduction and sustainability. But my concern is, and I'm trying to identify the lack of maintenance. And when you're saying the facades are covering the exterior of the pillars, so any damage inside you're not actually going to observe and therefore not do anything about, and that's a particular concern. And obviously, as you suggested, it's a situation where another event like the tsunami has an adverse effect upon those buildings, even 10, 20 years later, because of that deterioration has set in because of the salt water oxidization and so forth. And that's the very point I was trying to get to, was where that water was coming from for that oxidization happened, for it to explode, as you mentioned, and other deteriorations as well. And of course, once that starts to happen, we're going to see the buildings much more susceptible to damage for more minor events of seismic activity, because they don't have that structural stability. So yeah, thank you very much. And I think that's the point. Maintenance is really, really important. Biggest problem of buildings throughout the world is water penetration. So yeah, we need to watch that one.
Yes, certainly maintenance, especially for reinforced concrete structures, it's a major issue. And for countries in the, let's say, equatorial or tropical area, the issue of the recurrent monsonic activities and the flooding then creates a level of interaction with moisture that creates serious problem if it's not maintained regularly. Thank you very much, Gary. We have a question about rapid visual screening. So Joseph Patrick Rosal would like to understand what reference or what guidelines have you used for the visual screening and rapid assessment, whether you have used the ASCII guidelines or you have used some other format.
Yes. Firstly, we would like to thank you for Epicenter, especially for Rohit, and also Professor Tiziana that provided us with the rapid visual assessment form that so before we went to Cianjur for survey. So we discussed with Professor Rossetto about what your suggestion that we could do for the visual screening. So Tiziana said, yes, you please use this form and please refer to their work for this form. Yeah. So
Yes,
the one
maybe
that
Rohit, if you are online, would you like to comment? Rohit? Is online, but I think he had some problems from speaking from Nepal because he's in a school doing
Yes,
some.
I'm here. Can you hear me?
Yes,
Yes.
we can hear you. Yes,
Okay.
so I think the questions which you might want to answer is the rapid survey, rapid recognition forms that we shared with TDRR&RE. Where does it come from and how was it developed?
So it was developed initially for Indonesia itself, because when we went to Palu after the 2018 Central Sulawesi earthquake, and in the 3-4 hours, years later, we tried to modify and revise it based on our knowledge and the experience in those years, and it was a good form. First we tested it in Indonesia itself, and then we revised based on our experience elsewhere, for example, in different countries, different earthquakes, and then we significantly revised. Like, it was very much improved version.
So if colleagues are interested in listening to this webinar, we can certainly share that form on our website. Please go and visit it. Let's say that the underlying approach is not too similar to from the ACI 130, but we tend, the ACI 130 has the limitation that not all typologies are considered. It's prevalently used for steel and concrete. So structures such as the ones for schools that we have seen in Indonesia, which are, as I said, an intermediate between confined masonry and reinforced concrete frames, they cannot be immediately catered for. So we tend to let's say, tailor the rapid reconnaissance and collection data on visual screening on specific typologies. Yes.
Yeah, we try to literally follow the word rapid, because in field we want to correct as much and as many as possible. So it was very efficient form. It was designed to be efficient. Not too detailed in the field. So, yeah.
Yes, also the issue is that when we carry out reconnaissance missions, we are there only for a few days because we have limited resources, maybe 5 days, 10 days maximum. So it is important to have forms that are quite agile to connect. Now we have an app for that type of activity from EFIP, which again you can possibly access. And another form that can help you in terms of rapid visual screening and rapid assessment, and that leads you then to to assess and to define an archetype and a taxonomy, is the one that you can download from Glossy. And I will add here in the chat. I will add the link to that page. There is one more question from Shmuel Yerushalmi, and it relates to the interactions between the roof and the earthquake resistance of the frame, and how important is the maintenance of the roof in relation to the earthquake resistance of the frame. So please, Yunita, Rohit, close your, mute your.
yes,
you can
maybe I will talk a bit about the building roofs that you maybe seen with the Adrian presentation. It's mostly different. We have similar, I mean, typical structure from and then similar layout of school, a bit similar of typical layout of school from west of Indonesia to the east of Indonesia. But what make the like visually different from west to central and also to the east is the roof. So sometimes some schools, so we also went to 5 province in Indonesia, which is in the Kalimantan, and then several province in Sumatra and also in Java. Some schools like adopted their local traditional houses, like the different what make it different is the shape of the roof. And most of the schools in Cianjur, in the recent the place where the recent earthquake happened, it's using the clay tile, like Adrian said, and it's quite old and then a bit of heavy roof for us. I asked some of the the community there, the person, we went to one of the village, and then mostly of the houses usually use kind of that rooftops there, clay tile roofs, and they said because it is cheaper there in it's cheaper compared to other part of Indonesia for the clay tile roof there. And then for the tropical country, the clay tile roof is like can absorb, can reduce the heat to the room, and also it can reduce the noisy from the rain. But the problem is, of course, if the interlocking, because due to the interlocking between like the clay tile roof, it can like throw up when the earthquake happens, even though it's like the building is slight damage, but the roof makes the rooftop, the clay tile roof can be like throw up to like 1 meter from their place. So about the maintenance, I'm not sure with the newest construction whether they still consider using the clay tile roof or move into zinc kind of the roofs. And most of our school building here in Aceh is using the zinc, the kind of the lighter material compared to the clay tile roof.
So Shmuel, I hope this answers your questions. I have, if there are no other questions from the rest of the audience, I have one final question, UNITA and Adrian. You have used different damage classification in some of the collections. And from my understanding, there is a third classification in the guidelines in terms of damage. So how do you reconcile this when you make your consideration about the vulnerability of the structures in your country?
Yes, yeah. Even though it's a different number of damage states, but we could like but the correlation is still like not very distinct. Not very different. We may say that we start from the S0 for the UNDP Petra. We say that the data it's Indonesian like only have 3 damage states, but it can we can still like raise what do you call it, relook at whether it's to define whether the DS0 is
reclassify
of the damage state. And now I've got a small funding from the government to make an application for the rapid visual survey. So we have the previously we only have using the as three damage state. We're using for Lombok and for several events to what we call it for validating the application. But now after the because of the smalling funding, we want to upgrade our application that validating we using the data that from and then comparing the data from different classification of the damage state between like maybe from the rapid visual survey that being done with the epicenter from, and also from the government, because in the JUCNIS we also have different type of the different classification of damage state from the government.
Okay, thank you very much, UNITA. Yes, that I think that this work that you will now do on the homogenization of the damage of the different tools that you have for rapid surveys of the damage states, and then the reclassifications of the past database will be very useful in deriving vulnerability, empirical vulnerability functions for building in Indonesia, and it will be very important for various areas of resilience, for investments, and for both in public buildings, but also in insurance and private sector. That would be, that's I think if there are no more questions, that would be all. And we very much would like to thank again UNITA and Adrian for a great presentation and a very interesting, and I would like to thank all the audience for a very interesting discussion. And we look forward to meet you all again on 13th of July, if I will remember the date, at a slightly later time, 2 p.m. For the next installment of this webinar series. Thank you very much, everybody, and enjoy the rest of your day or evening or night. Bye-bye. Thank you.
Thank you, everybody. Thank you, Pravina.
Thank you very much. Thank you, Adrian, and thank you, UNITA.
Thank you. Thank you for supporting us. It's a kind of really supportive environment here. Yeah.
Thank you for supporting us. It's the first objective of this chair is to create this global network, and it's you supporting us in fulfilling these objectives, really.
Yeah.
So thank you again. And thank you to all that join from all over the world to listening to these conversations. And I look forward to receive information on which of the SDGs are you working towards. We have gone through midstream of the SDG, let's say, fulfillment. We are at the midterm. There have been a lot of activities in reviewing what progress has the world made towards fulfilling the Sustainable Development Goals. I think that some of the reports and some of the consideration at the high level are not so positive and so optimistic as they should be, or we are not quite where we want to be if we need to fulfill them by 2030. There are only 7 more years left. And although there are some progress, I think the actual activities are lagging behind somewhere. But it's very important that an increasing culture is developing there. And that's why I would like all of you to let us know whether you are, explicitly or implicitly working towards the fulfillment of any of the goals in any way, supporting schools, supporting the resilience of your communities, improving the greening and so on, and how that contributes towards the overall achievement. Because I'm pretty sure that besides what we know from the official channel, there is a lot of work locally that is done and that goes uncharted. And I would like to use our website and and our, let's say, brief to actually make, again, this activity known more worldwide and to a larger audience, because it's through examples that we all learn. So thank you again all for listening, and we look forward to see you in 3 weeks time now. Thank you. Bye-bye.